All right. Hey guys. We're gonna go over the next section, which is on intro to trig. So section 6.7. And so some of you guys are actually going to start doing pretty well in the last three sections of this unit, just because if you're already taking physics, then you should know what to do with all of this info for the most part. And if you're still hazy, even though you've taken physics, then this could be like a little refresher. But intro to trig or trigonometry, and it's worth noting that trigonometry is the study of sides and angles in triangles. So that's literally what trigonometry is. And math is the study of sides and angles in triangles. And so that's why we've been dealing a lot with triangles and similar triangles, and it kind of just flows nicely into the study of trig. Okay? So now that we know what trig is, let's focus on a couple of problems. So where it came about is this. Let's say we have a couple triangles. We have a right triangle where this side right here is 30 degrees. And what we realize is that when we have a 30, 60, 90 right triangle, the short side could be any value. In comparison to the hypotenuse, there's a ratio. You can either, depending on how you set up the ratio, it's either 2 to 1 or 1/2. That's usually what we do, is we usually go with the small side first and then the hypotenuse. And that happens anytime you have a 30, 60, 90 right triangle. And it didn't matter the size of the triangle as long as the angles matched up. So we could have had another triangle that's also a 30, 60, 90 right triangle. And we start to notice a pattern going on with the side lengths anytime we're given a 30, 60, 90 right triangle. And we can even go, even if the triangle is a little bit bigger, it doesn't really matter. It's still going to be the exact same setup, the exact same pattern. And that's kind of what trig really comes into play with, is that they realize, some of the old mathematicians realize that anytime the angle measures match up, you have similar triangles regardless of the size of the sides or the length of the sides. And so then they started to go away with it, and they just broke it down to its basic ratio of 3/6 or 1/2. So they realized anytime a triangle was 30, 60, 90, that the side opposite the 30 degrees in relation to the hypotenuse, the proportion was always going to be 1/2. And that's kind of where trig comes into play. It's all about noticing those proportions. And they gave some of those ratios names. And we have 3 trig ratios. Three trig ratios. So the first trig ratio is sine. And then we have cosine. And then finally tangent. So these are the 3 trig ratios. So whenever we're talking about a right triangle, let's see, and there's my right triangle. Let's say that we have an angle, and we're going to use this angle right here. We'll label that one theta. Excuse the screaming. We'll label that one theta. And in comparison to that angle, because this angle becomes my reference angle. So in comparison to that angle, this, if we draw a line, is the opposite. The side that it's touching, the leg that it's touching, okay? It's always going to be touching the hypotenuse, just as that way, but that's easy to tell which one is the hypotenuse. The hypotenuse is always the longest leg. So this is the hypotenuse, and then this is the side that is adjacent to that angle. Okay, so then we come up with the three trig functions that we have. We have the sine, cosine, and tangent. Sine, okay, is going to be, and it's abbreviated S-I-N, still pronounced sine, not sin, which I know a lot of you guys will do, but it is sine. Sine is going to be the side opposite over the hypotenuse. Cosine, the abbreviation for cosine is just COS or cos. Cosine is going to be the side adjacent over the hypotenuse. And then finally tangent. Tangent is abbreviated as tan. Tangent is going to be the side opposite over adjacent. So sine and cosine both use the hypotenuse as the denominator. Tangent does not. Tangent doesn't even use the hypotenuse at all whatsoever. So that's the three trig ratios in relation to our reference angle and our triangle, our right triangle. They came up with a little mnemonic to kind of help people remember the three trig ratios. The mnemonic itself, and I'm going to write it right over here in large letters. So, ka, toa. So, and if you realize, SOHCAHTOA, if you Google it, there are a lot of stories about Chief SOHCAHTOA, stories just made up pretty much to help you guys remember what the three trig ratios are. So, but SOHCAHTOA. So, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. TOA, tangent, is equal to opposite over adjacent. And for the most part, in the intro lesson, all they want you to do is just be able to write down these trig ratios. So the one thing that you are asked to do, say we're given a right triangle, and they give us the lengths of these triangles. Let's do 6, 10. Okay, so sometimes they'll go ahead and they'll give you all three sides, and sometimes they don't. But it's still a right triangle. You can easily find the three trig ratios. And then they'll label one angle as A, the other one as B, and so let's say that this is the problem that we're given, and we are asked to find sine of A, cosine of A, tangent of A, and then we will also do the exact same thing for B. But first, let's find this missing side. So we can use Pythagorean theorem here, 6 squared, and I'll just label this as B squared for right now, or B. 6 squared plus B squared is equal to 10 squared. So 36 plus B squared is equal to 100. B squared is 64. B is 8. Okay? So that's the extra step that we had to go through, was to find this. So now, sine of A, cosine of A, tangent of A. A is my reference angle. So everything is based upon this. So the hypotenuse is pretty straightforward. There's my hypotenuse. In reference to A, this is the side opposite. And then the other side that this angle touches, that's not the hypotenuse, is considered to be the adjacent side. So if I'm asked to find sine of A, cosine of A, and tangent of A, you're just going to write down the ratios and simplify them. So sine of A, if you remember back and you look at your notes or whatever you're writing things down on, sine of A is going to be opposite over hypotenuse. So to help you remember, let's write down. So TOA. Sine is opposite over hypotenuse. This is the side opposite over hypotenuse. So we end up with 8 over 10. Please don't leave it like that though. Reduce it down. 4 over 5. Okay. Cosine. Adjacent over hypotenuse. 6 over 10. Or 3 over 5. And then finally the tangent. We're going to go with the side opposite over adjacent. 8 over 6. Or 4/3. And that's kind of all you're really asked to do in this first section is on the intro, is just to get some practice on setting up these ratios. They will get more complex and more complicated as we move on, but for now, you're just setting up the ratios. Okay, so that's my setup for sine of A, cosine of A, and tangent of A. I'm going to delete this, and now let's figure out sine of B. Cosine of B and tangent of B. Okay, so now that we are focused on B, this becomes my reference angle, and so all of this information switches. So now, as B is my reference, this side is no longer my adjacent side. This side is the side that is opposite. This side with the 8 is no longer the opposite side. It's actually touching my angle. So this now becomes the adjacent side. And this doesn't change. Your hypotenuse is your hypotenuse. Okay? But you're still going to set up your ratios the exact same way. Sine of B is opposite over hypotenuse. Opposite over hypotenuse. So now I've got 6 over 10 or 3/5. Cosine adjacent over hypotenuse, 8 over 10 or 4/5. And then the tangent, 6 over 8. or 3/4. Okay. So, and if you actually take a look and compare the sine, cosine, and tangent, you'll see some patterns going on and some relationships between them. Okay. So that's the intro to trig. Like I said, it will get more complex. It will get more advanced. But these are just the basics. And this is all you really ask for in the beginning is just to take some time, learn the 3 trig ratios. I would definitely note SOHCAHTOA. It will come up many, many times over from now till you graduate high school. So